Two things are happening at once. Post-training for reasoning models is getting dramatically cheaper, and the real bottleneck is shifting from token-level loss to trajectory-level correction. In other words, the question is no longer just, can the student imitate the teacher? It's, can we keep the rollout on a good path long enough to learn from it? That matters for anyone shipping Qwen, Claude, or GPT-style systems at scale. And separately, the human side of AI is hardening too. People aren't becoming better detectors of synthetic text, they're becoming faster at policing it. Let's explore the first paper. Less is more early stopping rollout for on-policy distillation. This paper from UCLA and the Beijing Institute of General Artificial Intelligence argues that on-policy distillation can fail because late rollout tokens become off-policy to the teacher, causing off-policy teacher decay. The proposed fix. Early stopping rollout, ESR, is a one-line change. Stop student rollouts after the first end response tokens and compute reverse KL loss only on that early window. Across math, 500, HumanEval, and BFCL, ESR consistently matches or beats full rollout OPD across model families and scales, including Qwen 2, 5, Qwen 3, and Gemma, with student sizes from 1, 5B to 32B, and teacher sizes from 1, 7B to 72B. The method is especially strong in cross-generation and cross-family transfers, where full rollout training often collapses. On math, 500, ESR improves Qwen 2, 5, math 1, 5B, Qwen 3, 1, 7B to 65.85 AVG at 4 versus 62.35 for OPD, and on HumanEval, it reaches 42.1 pass at 1 versus 40.2. It also cuts per step wall clock from about 194S to 8S, a 24 times speed up, while reducing peak memory from 63.3 gigabytes to 24.1 gigabytes, about 2.6 times lower. Mechanistically, the authors find a cascading alignment effect, where training only the first 100 tokens lowers KL by 30–40%, even on untrained later positions, and a sub-mode commitment effect, where reverse KL distillation steers students toward a supported teacher submode and can even surpass the teacher. Let's explore the second paper, references. This study by Jason Micklien and John E. Katsos examines how Reddit and Hacker News users responded to LLM-generated writing by analyzing about 25 million comments from 2023 to 2026, with per-comment classification done using Claude Opus 4.7 from Anthropic. The core finding is that readers did not coordinate on a more accurate detection signal. Instead, they rapidly enregistered a pejorative accusation register centered on AI slop, whose share of accusation-like comments rose from 2.5% to 26.6% on Hacker News and from 1.5% to 24.4% on Reddit, while older inauthenticity, terms like shill and astroturf, stayed flat or declined. In a match control test of 421 accused parent comments against 2,048 length matched controls, prose markers that distinguish AI-generated disclosure text from human accusation text, such as lower contraction rate, higher formal adverb density, and greater sentence length variance, did not predict which human comments were accused, falsifying the idea that these accusations screen for AI at the lay level. The social function instead shifted from mockery toward gatekeeping and structural protest, with slop accounting for 94% of pejorative mentions by 2026, and the overall sentiment of confirmed accusations becoming more negative over time. The paper argues that this is a case of substitute signaling without screening accuracy, a community-level authenticity police language that survives because it performs boundary maintenance and status signaling, not because it reliably identifies AI-authored text. Let's explore the third paper, Trajectory Refined Distillation. Trajectory Refined Distillation, TRD, from McGill University, Mila Quebec AI Institute, and UT Austin, argues that the main weakness of on-policy distillation in Qwen 3 style post-training is not token-level loss noise, but prefix failure. Once a rollout enters a wrong reasoning path, dense per-token KL produces a bimodal teacher distribution and a fragmented gradient that cannot reconstruct the correction path. TRD fixes this by adding a trajectory-level refinement step, where a raw student rollout Y-O is rewritten by the teacher into a refined trajectory Y-R before standard distillation. preserving on-policy support while moving supervision onto the correction path. Across Qwen 3.1.7b and Qwen 3.4b, instruct 2.5.0.7, and across OPD and OPSD, TRD is consistently best or tied best on 7 of 8 benchmarks in each OPD block, with especially strong gains on AMObench. Hasset 16 rises from 12.8 to 17.9 for Qwen 3.1.7b, and from 23.1 to 35.9 for Qwen 3.4b. Instruct 2.5.0.7, while the Qwen 3.8b OPSD setup reaches 61.5 on AMObench. The method also broadens reasoning coverage, reducing refined corpus verifier failures from 65.8% on Y, O to 81.4% on Y, R for Qwen 3.8b, compressing median trajectory length from 7K to 0.88K tokens, and cutting total wall clock to 920 versus 9 to 40 for vanilla OPSD. The paper's key claim is that trajectory level correction, not loss clipping or top K token filtering, is the right scale for fixing prefix failure. That's a wrap on today's AI paper highlights. Thanks for watching.